Hey guys, today what we're going to do is we're going to talk really quickly about something that I know has been confusing for you guys. We're going to talk about degree of uncertainty. So here's how this is going to look like. You're going to get a question like this. This question is from lab 1.2, and it says, using questions 7 and 8, find the length of the pencil. What you'll notice about three of these options is that they're all very, very similar. C that says 18.9 is very similar to D that says 18.91, is very similar to B that says 18.910. So if you're looking at this measurement, it might be hard to tell, hey, kind of which one is the most correct one. Just so you're aware here, we're not asking you guys to tell us the difference between these three measurements. We're not asking you to measure to the thousandth place and compare which one is accurate. Instead, what we're asking you to do is we're asking you questions about degree of uncertainty. So remember, degree of uncertainty states that some of these numbers here will be numbers that we know because we see lines and we know them. And then the last number here will be the number that we do not know. It'll be the number that we have to make a guess based on the white space in between lines. So in this case, the correct answer is D, 18.91, which means that this last number here, this 1, is the number that's a guess. So it couldn't be C because you can go one extra place because you have those three numbers. It couldn't be A because you have 19, it's on 18 and you have a couple other numbers that you can figure out. And it's not B because that 0 would be a second degree of uncertainty that we cannot guess. So that's why the answer here is D. Let's go over a little more visual process to show you kind of how you can tell what your degree of uncertainty is. Okay, so here's a basic line being measured by a ruler, and you'll see here that the scale is 1 to 10. This is what a scale could look like. You could also, in this case then, the best guess number would be 8. This number right here is our degree of uncertainty. It's our first number, and it's also the only number we can say because we don't know exactly where this number falls, where this measurement falls on a scale of 1 to 10. So 8 is our best guess. So if this is the measurement we're given, 8 is the correct answer to that. Now, another correct answer could be 9 maybe. You could also maybe make a case for 7. 8's just the number I'm going with. Does that make sense? So this blue number here would be the only digit you would have. If we have a more specific ruler, now we've got measurements in between 1 and 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now we can add one more digit to this measurement. So we have to make a guess here. Is it between 8 and 9? And I might say something like 8.6. A number like 8.5 would be a great answer to that. A number like 8.7 would be a great answer to that as well. But it has to have two numbers here. Lastly, if we were to add in another 10 little purple guys here in between each line, now this one's kind of harder to see, but you can see that it falls between maybe the 6th and the 7th. So in this case, we can add one more number here and say 0.65. So in this case, the 5 here is saying it's between the 0.6 mark and it's between the 0.7 mark. So that's what degree of uncertainty is. Now what I want to do is I want to, for each one of those, for each, whether it's 1 through 10, or it's the red or the purple, I want to talk about what could be correct answers and what answers would be considered incorrect. Here we go. Okay, for 1 to 10, correct answers would be things like 8 or 9 centimeters. I kind of said that already. Incorrect answers would be something like 8.6 centimeters. Here, that 0.6 is a bridge too far. We can't say both the 8 and the 6 because there's not enough data here to even say the 8. 8 and 9 are uncertain numbers, so we can't have two uncertain numbers. 8 and 6 cannot be our two uncertain numbers. Same thing with 8.0, same thing with 9.0. Again, we have two uncertain numbers. We're only supposed to have one in our measurements. Here in this case, 8.60, even though that's closer to what the actual measurement is, we cannot say that because we're having two now we have 3 uncertain numbers. The 8 is the one uncertain we're supposed to have, but the 6 and the 0 are 2 other uncertains that we cannot have. We cannot be that specific in our guess, even though it is a good guess. Okay, moving on to the second one. Now we have the lines 1 through 9 here. So a correct answer would be something like 8.6. Again, the 0.6 here is a guess. The 8 is for sure. So we have 1 degree of uncertainty, our 0.6. Another correct answer would be something like 8.7. Incorrect answers, 8.60. Again, we have 2 degrees of uncertainty. The red number and the purple number are both uncertain. We only want one uncertain number. 0.65, even though, as I showed you in the beginning, 0.65 is actually the correct answer, we cannot write that 5 down because that would be a second degree of uncertainty. 0.70, again, 0.70 and 0.60, even though those numbers are exactly the same numerically as 8.7 or 8.6, how we record things in science states that 8.6 and 8.7 has 1 degree of uncertainty, 8.60 has 2 degrees of uncertainty, 8.70 has 2 degrees of uncertainty. So these 8.60 and 8.70 are more accurate measurements or more precise measurements. I don't know which one you would actually use there. But the 8.6 and 8.7 are the correct measurements because we cannot be that accurate with our information. We only have red lines here, so we can only say 0.6 or 0.7. 9 would be an incorrect answer because it's not specific enough. Same thing with 8 centimeters. Those are not specific enough. We need to make a guess here. Where is it between the 8 and 9? So we always need just 1 degree of uncertainty. We can't have 2 like these purple numbers, and we can't just have 1 like these numbers that are only blue. Okay, now we're adding in the purple lines here. So correct answers would be something like 8.64. 8.65 or 8.66 because it looks like this line falls right in between the 0.6 and the 0.7, kind of in the middle. So I'd say anywhere around there. Those would all be correct answers. Some incorrect answers. You couldn't say 8.60. You would only say 0.60 if this line fell directly on one of the purple lines, if you could kind of line those up exactly. You wouldn't just say 8.6 because, again, at this point, with these purple lines, we can make an estimate that's a little bit more specific. You wouldn't say 8.7. Again, we need a degree of uncertainty, and 8.7 would actually be incorrect because it looks like it's beneath the 8.7 mark. 9 would be incorrect, and 8 would be incorrect once again, just because we can be more specific. We know it's exactly at the 0.6 mark, and then we have to make a guess. So these have just one correct answer, or one correct number. We need another correct number, and then we need an uncertain digit for this specific measurement. Okay, last one here, 8.650. Again, this might be the same number numerically as one of the correct answers, 8.65. However, this 0 is stating that we have 2 uncertain digits. The 5 and the 0 in this case are both uncertain. We only want one uncertain digit, the 5. So this is considered an incorrect answer because it's too accurate based on the measurement we have. If we had lines in between the purple lines, then we could put the 0 in here. Unfortunately, we don't. So we cannot include the 0 there. Again, 0.55 would be another one that we cannot do just because that thousandth place here, the second 5, is too accurate of a measurement to make with this ruler. Okay, I hope that helped you guys understand degree of uncertainty and when to know how many decimal points to use. We're going to talk about this in class. Also, if you have questions, feel free to email me about this. Thanks. Goodbye.